Good. So I like what I'm hearing so far. I hear f of x. I hear plug in. Anything else? A table. Okay. So yeah, you get a graph. So some people make an XY table. You can make an XY table even for things that are not functions. For example, you graph something in the last unit that is technically not a function. Anybody know what they graphed in the last unit that's not a function? Starts with a C, rhymes with Urkel. Circle. Yeah, you graphed a circle. A circle's not a function. Anybody know why? It fails the vertical line test. Remember that idea? So we're going to talk more about the vertical line test in a while, but right now we need to get down the definition of a function. And before we do, I'm going to share with you what it is so it makes more sense, okay? We got a soccer player here. Who else soccer player? You got one? Anybody else? Okay, two. Okay, all right. Is it possible for these two gentlemen to both score 3 goals in a game? Yeah. Is it possible for both these gentlemen to score 0 goals in a game? Is it possible for Tony to score 1 goal and Mike to score 0? Is it possible for Mike to score 10 and for Tony to score 20? It's not likely, but it's possible, right? Okay? So what we have here is they are the inputs and they're outputting goals. Is it possible for Tony to score 2 and Mike to score 1 and 5 in the same game? Is it possible to look at the newspaper and say, oh, the total number of goals that Mike has in that game is 1 and 5? You would say there's a misprint, right? Because every input has to go to just one output. If it doesn't, it's not a function. Now notice, can the inputs go to the same output? Can they score the same number of goals? Yeah, they could have the same output, but they can only go to 1. So the definition of a function, you'll memorize this perfectly for the test, and we will practice it. It goes like this. A relation, and a relation is just a set of points, okay? A set of points. A relation in which every element of the what? Everything that's in the input, instead of input, we use a word starts with a D. Everything, every element of the domain, so those are your inputs, okay? Those are your x values, corresponds to exactly how many? 1 element of the range. A relation in which every element of the domain corresponds to exactly 1 element of the range. I was in college taking a real analysis course, which is a full proof-based course, and we were all pretty smart people. A professor walked in front of class and said, can anybody tell me the definition of a function? Not a single one of us could do it. I will not be that teacher. You will know it, and you'll know it well, and you'll never forget it, which is beautiful. All right, you go do that. Yes. So does it make sense in how we did the soccer piece? So let's look at the mathematical abstract of it, okay? So you can have a table of values. You can see the relation is this set of points. Often I list the x values in order. So if I list the x values in order, what are they? Yeah, -2, 2, and 4. And then the y values have to correspond with those x values. So they are going to be what?
0, 4.
Yeah, okay. So it says domain and range here. We're just going to put the domain here and the range there just to kind of save time. I want to make sure that we can get to the pieces of notes that we need to get to so you can start working on your assignment. So the domain are the elements -2, 2, and 4. And the range are the elements, we have -3, 0, and 4. So when we determine if something's a function, we look at the mapping. What is -2 for the domain map to in the range? It maps to 0. So did -2 go to just one spot? So that's okay so far. What does 2 map to? 4. And 4 maps to -3. So is it a function, yes or no? It is, because each of these just goes to one range output. If you were to actually plot these, -2, 0, that would be right here. 2, 4 would be over 2 and up 4. And 4, -3 would be over 4 and down 3. So let's go to Rachel's idea of this vertical line test. Are there any points that sit on top of each other? So we know by the vertical line test then that it is a function because there's no points that sit on top of each other. I brought this not because you're going to do this in your assignment, but try to bring relevance because this is the same kind of organizer that Miss Kruger used with you and Miss Hanson used with you when you talked about this subject. Do you remember kind of those shapes a little bit? Good. That should provide relevance to your brain and prime you for learning. Okay, so we move along. Okay. This one is just slightly different. Okay. I'm not even going to list the table values just for the sake of time. I'm going to go straight over to the mapping process for domain and range. So what are the x values that I have? I have 1 and I have -5. What are my range values? Yep, -3, 4, and 6. What is it that -5 corresponds to? It corresponds to 6. What does 1 correspond to? Yeah, so is this a function? No, it is not a function, okay? If you were to graph these points, you can see you have over 1 and up 4. You have back 5. And up 6. You have over 1 and you have down 3. So as you plot those, do you have a point sitting on top of another point? So that tells us, according to the vertical line test, this is not a function. So just to kind of make my point one last time through, suppose I had a different scenario. Suppose I had this. Suppose I had 1, 2, 3, and 4, and over here I had 1. Is that a function? Talk to your friend, yes or no? Is it talk to your peer? 5, 4, 3, 2, 1. Yes or no? Yes. They are each going towards one spot. And again, I try to use the idea, is it possible for numbers 1, 2, 3, 4 on the soccer team to all score 1 goal? Is that possible? Suppose I have the number 2 here, and now the number 4 scored both 1 and 2 goals in a soccer game. Well, then that's not possible. Okay, so that's then where it fails. We all good? Okay, let's get to the algebraic and the evaluation point where we do these expressions. You see that the way that we, and by the way, why is it so important to learn functions? And you're going to be able to graph functions really well at the end of this unit. You're going to gain some really good skills that you didn't have before. It's going to be super useful as we go through the rest of the year. But why do we like functions? Functions are very useful in, first of all, they involve real life. Second of all, they're very useful in calculus. Super, super nice to work with functions in calculus. So this reads, instead of y equals 3x minus 5, y and f of x are interchangeable if it is a function. So when we're asking to determine f of x, we just want to know the y value. And this is the fancy way of saying, if we plug in -3 for x, what's the y value? That's the language of mathematics. If we plug in -3 for x, what's the y? If you notice, I just put a -3 wherever the x is. So I have 3 times -3, and I subtract 5. What is 3 times -3? Minus 5? -14. Okay? It says to evaluate f of 0. So now I take my x, and in the place of x, I plug in a 0. 3 times 0 is 0, minus 5 is negative 5. F of 2. What do you get if you plug in 2 to your function? Yep, 3 times 2 is 6, minus 5 is 1. What's different about the next operation? It's a variable, which may seem silly to you. However, we do it in calculus all of the time. In fact, the test that they just took, which was handed in, has all sorts of these expressions that get plugged into functions. So we got to learn how to do that. The first one is pretty easy. We plug in a. How do I plug in a? Where does it go? Yeah, it just goes right in for x, so it becomes 3a minus 5. And that may seem silly right now, but tomorrow it sure isn't when we move on, and you're going to see how it gets used. And now I plug in a minus b. It says f of a minus b. And as I show plugging something in, just like we plugged in a negative x when we were testing for symmetry in our last unit, I'm going to plug in an a minus b. And again, I like to show parentheses so that way we can see what happens. Now, on the test, I'll ask you to write it without parentheses. So distributing and combining like terms if you can. This ends up being 3a minus 3b minus 5. And that's what we get. Pretty straightforward. Please try the next one on your own. Okay, let's check those first four. I've got 15 for the first one. I've got 0 for the next two. And I have a squared minus 2a for that fourth one. Are we okay with that? Okay, then please don't do this. This is what will drive me nuts. Okay, so you plug in a negative 3. Lots of times people do this. Negative 3 squared. Well, 3 squared is 9 times negative 1 is negative 9. We all understand that that's not accurate. And some people type in their calculator this way. They're like, well, my calculator told me. Well, yeah, your calculator squares the 3 that multiplies by negative 1. You need to plug it in like that. Okay, so when we substitute something in, you use your parentheses. For this situation, want to talk about this because this is not as always as intuitive. So I'm going to walk through it, just make sure we're all on the same page. How do I square a minus b? Good. So we sometimes refer to that as FOIL. I multiply the two binomials. And a times a is a squared. Let's look at what happens in between then. I have a times negative b, and I have a times negative b. Notice how those are the same? So what do you get in the middle? Negative 2ab. It's double those. You okay with that? Because that's going to happen a lot. So, you know, if you need to see that again sometime, let me know. We'll talk about it. And negative b times negative b is positive b squared. Minus 2a plus 2b. That's our expression. And that may look ridiculous. It's extremely useful, okay? Extremely useful for us. We want to do a and b here, then a and b on the top side, and we'll be done for the day, okay? Let's, we got to practice fractions because we're not very good at that, okay? As an entire group as a whole within the school, we all tend to struggle with fractions. I want to make sure we can practice this. Let's do the easy one first. F of 4. Yep, that one was nice, right? So we don't worry about that one. But the next one, f of 1/4. That means, what do I plug in for x? 1/4. We are not allowed to have a complex fraction. We need to simplify 1 over 1/4. How? How'd you get that? You multiply by the reciprocal, okay? So this is, you know, it's multiplied by the reciprocal. The reciprocal 1/4 is 4, so you do get 4. We're all good with that? Okay, in the next situation, I have f of 3x. So I plug in 3x and I get 1 over 3x. No big deal. The next one, I plug in 5 over x. Yep, so I have 1 over 5 over x. Is that allowed? No. So you multiply by the reciprocal, which is x over 5, and we get x over 5. Are you okay with that? How about the next one, f of 4? What do you get on top? What do you get on the bottom? What happens if you have 0 in the denominator? Yeah, the mathematical term is undefined. We do not have a defined output if you plug in 4. So we would say that 4 is not part of the domain because you don't get anything out when you plug it in. F of 1/4, this will test us a little bit here. I have 1/4 in the top, and then in the bottom, I have 1/4 minus 4. How'd you get that? It's Mikey's birthday. You get math magic on your birthday. Nice job. All right, so this is a complex fraction. So what I'm going to have to do is I'm going to have to combine these together. If I want to combine these two, what do I have to find? Common denominator. So I'm going to rewrite this as 1/4 divided by 1/4 minus, what's 4 over 1 in fourths? 16/4. So now I have a common denominator. So I have 1/4 over negative 15/4. Now I can do that magic thing, which is multiply by the reciprocal. So times 4 over negative 15. And Mikey was very close. It is negative 1 over 15. The negative can go at the top or the bottom or go out front. You okay with that? What is f of 3x going to be? Yep. Piece of cake, right? But if we try f of 5 over x, what does that look like if I write it out? Good. 5 over x on top, then 5 over x minus 4. Yeah, so now we got to find the common denominator. And the common denominator, as Kenny says in this situation, is x. So I multiply the top and bottom by x. So I have 5 over x in the top. What do you have in the bottom? 5 minus 4x over x. Hopefully by now you can anticipate that when I multiply by the reciprocal, what's going to cancel? Yep, 5 over x times x over 5 minus 4x. 5 over 5 minus 4x. Can I cancel the 5s? Definitely can't cancel that. Definitely can't cancel. Good. Last part. Something new. Something new, something new, something new. Look confusing? Look scary? We're going to take something that looks confusing and scary. We're going to make it super easy. This is going to be super easy by the time we're done. Do you trust me? Because that's what I really need too, is I need you guys to trust me that I've gone through this before. I know what we're capable of, and I know where some of our limits are. I want to evaluate f of negative 3, f of 0, and f of 2. Any thought where I plug the negative 3 into? Should I plug it in the top one, the bottom one, or both? What do you think? That would seem natural. Like, let's have everybody get a share, right? Like, let's not leave somebody out. But this is the key right here, folks. It says to plug it into 2x minus 1 if the x value is less than 0. Is the x value less than 0? Yes. So I choose the top one. This is what we call a piecewise function. It has pieces to it, 2 different pieces. So I have 2 times negative 3 minus 1. What's 2 times negative 3? Minus 1 is negative 7. The second one, I have f of 0. Do I plug 0 into the top one or the bottom one? Why? 0 is equal to 0. And what are you going to get? You do get 0. F of 2, top or bottom? Bottom. I plug in 2 and I get negative 1/2 times 2 squared, which is 4, minus 3/2 times 2. So let's try to figure that out. What's negative 1/2 times 4? Negative 2. And what is negative 3/2 times 2? Negative 3. So it's negative 2 minus 3 is negative 5. That wasn't bad, was it? We end with this then. F of negative 3. Top, middle, or bottom? Top. What's 5 minus negative 3? 8. What's the cubed root of 8? Times 2? 4. F of 0. Top, middle, or bottom? Middle. It says 18. So there's nowhere to plug it in, is there? That just means it's always a value of 18. It's a horizontal line. It's a y equals 18. It always has a height of 18. And where do you plug in 2? The bottom. 9 times 2 is 18, minus 2 is 16. For your homework, you are able to work on problems 1, 2, 3, and 4. And as you flip it over, 5, 6, 7, 8. Do not try 9, 10, 11, 12 yet. Do not try 9, 10, 11, 12 yet. That's for tomorrow, tomorrow, tomorrow. We all good? Good job on your tests.